Hi, my name is Julian Vian. I work in the Operations Security team at Mozilla. I'm going to present Mozilla Investigator, a tool we've been building to perform investigation of incidents. MEG is a tool that we designed to investigate endpoints at a large scale. When we receive an incident and we have a large number of potentially compromised hosts, we use MEG to reduce that number to a small subset of hosts that we can look at manually. So MEG is a tool that we use to reduce the scope of an investigation to anything could have happened and all of these servers could have been hacked to we know these three have been compromised and we're going to freeze them and manually investigate what happened. How do we do this? MEG is a distributed platform. It runs an agent on each of the endpoint. The agent is built in Go. We use Go because Go builds a static binary that is very easy to ship to multiple platforms. It doesn't require external dependencies. MEG has a platform on the server side, and it uses AMQP, RabbitMQ, to communicate between the platform and the agents. The security relies on GPG signatures, and the investigators, human beings who want to use the MEG platform, will use GPG private keys to sign actions that are passed to the agents, and the agents will verify the signatures using ACLs and GPG public keys. MEG can do file system inspection. It can look inside a file for regex. It can look at file names. It can compare files against hashes, MD5, SHA-1, or SHA-56. We're working on memory inspection. We're working on firewall rules management, inspection, and creation of firewall rules. So if you want to block a given IP, you would send an action to the pool of agents telling them to create a firewall rules to drop traffic from or to that IP. We're working on discovering user accounts, discovering public keys on systems, and so on. The architecture of MEG uses a central platform that has an API or REST API, a JSON API, a Postgres database, and a scheduler. And the public part of the infrastructure uses RabbitMQ relays that are open to the internet. Agents connect to RabbitMQ relays using TLS client certificates and credentials. The agents are distributed on endpoints. The agents can be anywhere on Linux, AMD64 or 32-bit systems, Mac OS, Windows. We are even considering supporting other platforms in the future, but for now, only these three are supported. The security of MEG relies on GPG heavily. Investigators have a GPG private key. In order to interact with the agent must recognize the public key of an investigator as valid. If the platform is compromised, whoever compromised the platform will not be able to interact with the agents as long as the private key has not been compromised. There is no single point of failure. Any component of the infrastructure can go down and recover without losing data. We have fine-grained ACLs, which means we can give access to administrators or investigators without giving them full access to the entire platform. Some of the requirements include being very lightweight. We've used other tools for investigation before, and a lot of them have a bad tendency to use 100% CPUs on servers, which is unacceptable on production systems. So low CPU usage and low memory footprints are requirements. Right now we do that by limiting the execution time of an action on a system to 30 seconds. In the future we will be controlling memory consumption and CPU usage more closely. The agent must be portable and run on multiple platforms and very easy to deploy. The agent must be asynchronous. The goal is that if a system is down, the system will come back online and eventually pick up the work that's waiting for it. It's fine if not all of the responses are received at a given time. We could imagine that an investigation extends over 3 or 4 days and all of the systems process the action as they see it. So if a system wakes up after 2 days, it will pick up the work and send its responses. And fast. So a good way to imagine MEG is as a MapReduce job. There is a central scheduler that sends jobs to lots of agents to look for specific indicators of compromise, and these indicators come back, and then the scheduler and the API will reduce the scope of the investigation and send back a result to the investigator that's very minimal. MEG is not used for permanently monitoring systems. Its goal is not to monitor live traffic on a system for long periods of time. Its goal is not to look for syscalls on on a system for long periods of time, or to read the logs of a system. We use other tools for that. MIG is also not designed for data extraction. You could imagine taking or triggering a memory dump of a system through MIG, but retrieving that memory dump would have to be done through another mean. The goal here is to protect privacy. If we run MIG on user endpoints like laptops or phones, we do not want to give capabilities to retrieve data that could belong to the user. It will have to be done with the agreement of the user and through a different mean. So you can look for more information on the GitHub repository, and the documents are linked here. I'm going to give a quick demonstration of the console now so you have an idea of how to interact with it. Here, this is a MIG terminal. We can search for agents that are active using the name. So for example, here I'm looking for an agent that is called something obsec. And I can see, if I put only one S, the latest version of the agent that I started. I can look at the details of the agent, and here I see that the agent has checked in 15 seconds ago. So now I want to run an action on all of the agents. I'm going to look for, let's see, I'm going to search for an action that runs several tests. Okay, I have here integration test. Let's look at this action. We can look at its detail. We see that this action here will run the file checker module, and it will look inside various paths for various regexes. It will look, for example, inside etc/yum wildcard.repo and verify that the repositories are using gpg check equal 1. Okay, so we can copy this action to launch it again. So we're going to set the times of the action to start now and to expire in 60 seconds. Now we can look at the times, and we see on the first line that the action will expire at UTC time 1912. Now we can sign the action. What happens in the background is that the console calls GPG agent on my local machine, performs a GPG signature of a few of the JSON field of the action, and embeds that signature inside the body of the action here in the PGP signature field. So my action is signed, it has proper time, so I can launch it now. And what happens is the console connects to the API, pushes the action to the API, and the API will push it to the scheduler and to the agent. Here it didn't work because I have a target that is not valid. So I can try to send the target to something a little more broad and launch my action again. And here we'll see that the action will run on several hundred systems. And the console will wait for the action to complete. This usually takes between 15 and 30 seconds. So you can imagine it as a more powerful version of PSSH or cluster SSH, but you don't have to manage the output or to manage nodes that may not have SSH accounts or may fail. MIG does that for you, and it handles the communication for you. So here we see the progression, 75% done. Now if some agents do not answer to the action after the 60 seconds have passed, the platform will expire the action and finish it. And we have only 2 agents that have not replied. Okay, so here's what is happening in the background. Agents will receive the actions in JSON format and validate that action. When the action is valid, it will take the body of the operation and pass it to the module. In this case, the file checker module. But there could be another module, like the connected module, that will look for IP addresses currently connected on the system. The PCAP module could look for, could start a PCAP dump of the network interface for 1 or 2 minutes and look for specific traffic. The memory module, etc., etc. So here the action completed in 1 minute and 11 seconds. We can look for nodes that may have returned positive results. There you go. Those are all of the nodes that have returned something positive. So this is a quick overview of what MIG does, and I encourage you to check out the GitHub repository and set it up yourself.